two-step equations. Look at an example here. So this is a pretty popular looking equation, so let's go through the steps to solve something like this. So you have to use additive inverses or multiplicative inverses, which are basically saying our opposite. So in this case, I'm going to solve for x, so I'll subtract 4 to both sides to maintain my equality based upon my equal sign. As I do that, I get positive 9. Now the opposite up here was to subtract a 4 to both sides. The opposite here is I'm multiplying, so I'll divide this time, and x equals 3. Negative 5x plus 6 equals 16. In this case, I will subtract a 6 first. Alright. Those are opposites, they add to 0. Then I'll divide, and x equals negative 2. Look at another one here. Negative 8y minus 4 equals 28. So a lot of times people think of it as you're getting rid of the 4 or the negative 4, and you are, but you're doing it by using an opposite, and they don't really go away as they add to 0. Okay. So I do the opposite, right? And that's going to give me a 0 pair. They're going to add up to 0. And over here, I'm going to make this, it's not going to go away as well, but I'm going to turn it into a 1 by dividing by the reciprocal, or multiplying by the reciprocal. And we get negative 4. All right, we'll look at one last example. So you can see a pattern there, but they can write these in different ways, different orders, and we got to be able to adjust to that. So if you look at this one, this time they put the term with the variable second, but it doesn't change in the way that I have to deal with it. So I'm going to get rid of that negative 18. So I'm going to add an 18 to both sides. And so I get negative 3x, that negative is attached to that 3. I get a negative 39 over here. Divide by a negative, and I get positive 13.